These are the notes that accompany section 11.2.3 from the CPM Integrated 3 textbook. These are going to be our last notes for the fall semester. Yay! So we're going to be talking about solving 3x3 systems. So this goes a lot back to systems of equations that we did as an essential skill for this semester. But instead of having 2 equations with 2 unknowns, we're going to have 3 equations with 3 unknowns. We're talking specifically about a 3x3 system here. So, but the idea of still doing really what our brain only functions with, and that's in pairs of things. So what you're going to do is you're going to pair 2 of the equations together. Doesn't matter which ones. And you're going to eliminate the same variable. Ultimately, you're going to eliminate the same variable twice. So I always think about this as double elimination. You want to double eliminate the same variable. Then we're going to, with those double eliminations happening, now create 2 equations with the exact same 2 variables. So either x and y, or x and z, or y and z. Now we're back to what we've done before. So if we can get the double elimination part handled in the beginning, that's really the only thing that's different. And then handle our 2 equations with 2 unknowns. And then ultimately, we want to make sure that we write our answer as an ordered triple. So let's go ahead and take a look at this. A lot more organized for the first one, so just kind of follow the idea of what we're doing here. And then the next example after this is far more freeform. So like, here's a big empty space, you decide how that you want to set this up. So we want to take a look at these 3 equations. And we are going to eliminate. So I like the idea that all the x's are stacked up, all the y's, all the z's, equal signs, and constants. And just pay attention and see which one you think might be the easiest to eliminate. So if I take a look at my x's first, so let's grab my highlighter here. Notice that if I pair any of those 2 up together, nothing's going to eliminate immediately. So I would have to multiply at least one of the equations. So if I multiplied or tried to hook up the first 2 equations, I'd actually have to multiply both of them to get the x's to match. If I did the first and the last one, I'd only have to multiply one of the equations, so that's good. If I did the second and the third one, same situation, you'd have to multiply both of them. So path of least resistance, okay? See if we can make this as easy on ourselves as possible. I'm going to take a look at the y's. I do like this one better because the last equation has just a plain old negative y. It doesn't have a number attached to it. So I think multiplication of one equation would probably be good here. But if I pair those 2 together, so my 3 and my -2, you're going to have to multiply both of them. If you multiply the first and you pair up the first and the last, you only have to multiply the last one. If you pair up the second and the last, you only have to multiply one of them. So it sounds like we're going to have to multiply at least one of the equations a couple of times. Okay, let's take a look at the z's. I actually like this one the best because if you take a look at the very first 2, they're already ready to eliminate the z's. No multiplication necessary. Then I can either pair up the first one and the last one. I'd have to multiply by a -2 to get that to happen, so that's okay. Or I can hook up the second and the third one and have to multiply the second equation by 2. So I'm looking for what I think is probably going to be the easiest one. And I'm going to choose z. So I'm going to double eliminate z. So that's my plan. Not that it matters. You get the exact same answer regardless. You just got to be careful. Okay, I think I'm going to hook up the first and the second one. So let's bring those equations down. So I'll bring 2x plus 3y plus z equals -20. My only recommendation above and beyond, make sure that you know what you're doing in the question, is make sure you're writing the question down correctly. That's really the big thing here. So my first equation, 2x plus 3y plus z equals -20. Okay, copied that down correctly. -5x minus 2y minus z equals 8. Copied that one down correctly. All right, if I add straight down, the z's go away. That's the whole point. So this is going to give me a -3x, a plus y, and a -12. This is going to be one of my new equations. I'm going to call this, so if you refer back to the notes, I'll call this equation D. Now, I got to pair them up again. So I can't pair up the exact same two equations, so I'm going to get the exact same resulting equation, which isn't going to get me anywhere. And this was me pairing up the first one and the second one. So back to, I think I'm going to go with the second and the third one. So I'm going to bring down my second equation. So negative 5x minus 2y minus z equals 8, paying very close attention to my equations here. Let's erase that. Get rid of this as well. Okay. I'm going to get rid of the z's. So I'm going to take this entire first equation and I'm going to multiply it by positive 2, because then that will get me to match the 2z on the next one. So if I multiply that through, get negative 10x minus 4y minus 2z. Got to be careful about my 2's and my z's. They have a tendency to look the same. Copy down the other one. And then if I add straight down, the z's go away now. So that's good. So let's add straight down. It's going to give me a negative 14x minus 5y. Z's are gone. And then positive 16 and negative 14 is 2. All right, I'm going to call this equation E. Now, if you look, if we did this correctly, the two equations that we created, D and E, now have the exact same variables in them. They both have either x's and y's or x's and z's or y's and z's. Now we should be able to continue kind of like we did previously. So I'm just going to copy those down. So I've got my negative 3x plus y equals negative 12. I'm not doing anything to them yet. I'm just copying them over. Negative 14x minus 5y is equal to 2. Okay, now you have to figure out what you want to eliminate again. Now, we already eliminated z. So now it's down to x's and y's. Path of least resistance. I think I'm going to do the y's, because I only have to multiply the very first equation. And I'm going to multiply it by 5 to get those to match. So that'll give me negative 15x plus 5y is equal to negative 60. And then I'm just going to copy down the other equation. Negative 14x minus 5y is equal to 2. If I did this correctly and I add straight down, my variables should disappear, which they do. So my y's are gone. So it gives me negative 29x, negative 58. All right, home stretch. Divide by negative 29. Looks like we have x equals 2. So there's part of the answer. Now, I'm going to go ahead and just stay in this box, so this little area here. I'm going to look back at the two original equations that I used here, D and E. Pick the one that you like the best. I think I'm going to go with equation D. And I'm just going to copy equation D down. That's all. So negative 3x plus y is equal to negative 12. You know what x is. Plug it in. Gives us negative 6 plus y equals negative 12. Add the 6 to the other side. It looks like y is going to be equal to negative 6. Okay, we're in the home stretch. Last thing, solve for the final variable. So I have x, I have y, I do not have z. This is where you have to go back to one of the originals. So if we take a look back on the previous page, these equations would have been identified as A, B, and C. You have to pick one of the ones that you started with that has both x and y in it, that doesn't have, well, it still has z in it, you just don't know what it is yet. So, I don't know, let's see. I think I'm probably going to use b. And I have no reason for that, honestly. So pick whichever one you like the best. Copy down the equation. So negative 5x minus 2y minus z is equal to 8. And then plug in what you found. For x, we got 2. For y, I don't want to keep that y in there. For y, we got negative 6. And I don't know what z is. That's what I'm trying to do. So it's negative 10 plus 12 minus z equals 8. So that's 2 minus z minus the 2. Looks like negative z is equal to positive 6, which means z is equal to negative 6. All right, last thing we need to do is just write the answer. So our ordered triple in alphabetic order. So x, y, z. And one of my recommendations, and I always do this personally, is I plug those in for x, y, and z into all 3 of the equations I started with in the first place, just to check my answer, make sure that what I got is right. Okay, infinite solutions versus no solutions is kind of a big deal. You do have stuff where it looks like all of the variables disappear. So variables suddenly all disappear. That's the key thing, all disappear. If what you get is not true, there's no solution. If what you get is true, that means there are infinite solutions. So just like what we did previously. Okay, I'm going to go through. Notice this is kind of the free form one, so you decide how you want to organize this. Take a look at the original equations. So x, y, and z. I think I'm going to get rid of x, only because I have that positive x and that negative x. And those are actually the ones I'm going to put together first. But again, it's totally your choice. So we're going to double eliminate, or that's what I'm going to do. So I'm going to double eliminate x. You could choose y or z. Doesn't matter. We'll get the exact same answer. So I'm going to take the first 2 equations. So x plus y plus z equals 3. Excuse me, the first and the last. Make sure that I wrote them down correctly. I did. Add straight down. So there's one of my equations. So 6y plus 2z is equal to 26. I'm going to go ahead and call this equation D. So I eliminated x, which means I need to eliminate x again. I think I'm going to use the second and the third one. So I'm just going to copy down what I got. So the second equation, 3x minus 4y plus 2z is equal to negative 28. And then negative x plus 5y plus z is equal to 23. Okay, I'm eliminating x, which means this entire second equation, I'm going to multiply through by 3. Slide it over. So I'm going to multiply through by 3. It's going to give me a negative 3x plus 15y plus 3z is equal to 69. And then I'm going to slide this over. So 3x minus 4y plus 2z is equal to negative 28. Add straight down. X's are going to disappear. It's going to give me 11y plus 5z is equal to, looks like 41. This is going to be equation E. So now I'm going to put D and E together, and I'm just going to stack them up next to each other. So let's go ahead and just bring this guy over, bring this one over. So I have 6y plus 2z is equal to 26. And then I'll have the other one, which is 11y plus 5z, which is equal to 41. and then you decide, do you want to get rid of x's or y's? Or y's or z's, sorry, we already get rid of x. I think I'm going to get rid of the z, because I think when I multiply, they turn into smaller things. They don't blow up so huge like the 6 and the 11 would. So I'm going to multiply the entire first equation by 5. I'm going to color code this to try to help myself out. So this is going to give me 30y plus 10z is equal to 130. All right. Now let's multiply this one by negative 2. So negative 22y minus 10z is equal to negative 82. If I add straight down, my z's better disappear. Now 8y is equal to 48. Okay, this is good. It looks like y is equal to 6. So that's one of them. Now you want to use equation D or E. It doesn't matter. I think I'm going to use D. So I'm going to take this, use equation D. I'll copy that down, which is 6y plus 2z is equal to 26. Plug in your y. So 6 times 6 plus 2z. That's 12. 2z, 26. Minus your 12 to the other side. Looks like 2z is equal to 14. This doesn't look right. Oh, 6 times 6. What am I doing? That's 36. Let's fix this. Minus 36. Okay, negative 10. Looks like z is going to be equal to negative 5. And then last thing, go back to the originals. Remember, you have A, B, and C. So that's A, B, C. Pick whichever one you like better. I am hands down going to use A because I think it's the easiest one. So I'm going to take my Y and my Z. I'm going to write down equation A, which was X plus Y plus Z is equal to 3. I don't know what X is. I do know what Y is. I do know what Z is. Looks like X is going to be equal to 2. And then write your answer as a triple. So X comes first, which was 2. Y comes second. Z comes third. And then I am going to do the same thing that I talked about on the previous slide. I'm going to plug it back into the original equation and actually make sure that these work for all of them, which I did, and they do.